Okay, so let's get started. We're going to be taking a look at working with our closed-loop lambda correction and tuning found within our Motec M1 programming. Now, our closed-loop lambda correction is something we absolutely want to have enabled, and we want to be able to both work in calibrating and tuning as well as long-term engine operation. What it's going to do is take a look at our measure exhaust lambda reading coming from our wideband, and that's going to be something we have broadcasted into the Motec. We can see that's coming in right here. It's going to compare that to whatever the desired target lambda is going to be from all of our target lambda tables. So it's going to look at the difference between the measured exhaust lambda and the desired target. And there's always going to be some kind of a deviation or difference. Depending on how far we're off between those two, it calculates something known as lambda error, the difference between the actual and the measured exhaust lambda. Now that lambda error is used in a closed loop correction, meaning it takes a look at whatever the injector pulse width is calculated from our normal air and fuel model. We're going to have a deviation measured somewhere in there, so we find that we have this lambda error calculated. Now we're going to allow the Motec to make a percentage adjustment to that, whatever that pulse width is calculated from the air and fuel model. It'll add a couple percent or take a couple percent away so that we are hitting the desired target lambda spot on at any given operation point, idle, part throttle, or wide open throttle. So we utilize this within our calibrating and tuning process, dialing in our VE table, for example. We also use this, again, if we're not hooked up to the Motec, we're running it in, let's say, different seasonal changes. We're going from winter, and then we're going into spring where we have a decent temperature swing. We'll find that we may have something not modeled exactly right within our air charge or the density aspect of our airflow model, and we may not have our fueling quite right. It might be off a few percent. Well, the closed loop correction will allow us to correct for that. It'll take up those little bit of deviations or differences day to day or in seasonal changes and allow you to have an engine that's running always at that desired target lambda. So what we're going to do in this training module is do an overview of our closed loop control, and then we're going to take a look at just some of the aspects within the programming, understanding how this all fits together. The next training module will do a live demonstration of going through a couple key points, setting up the gain, for example, and how to set up the period table. We'll describe it in this tutorial, but I'll actually show you in the next training module so you have a better idea what's going on with that. Let's jump in here and take a look at where we can find turning on and working with our closed loop control. So we're going to move from our field tuning window and jump over here to closed loop lambda. Under our closed loop lambda window here, we're going to find that we have our main target lambda table. So this is going to be where we specify our desired target lambda. Before we turn on and work with the closed loop control, we absolutely want to make sure that our main lambda table here, the target lambda table, is configured and set up. Now I've had a specific tutorial dedicated to what values to put into this desired target lambda table, whether we're naturally aspirated or forced induction. This particular table is configured only up to 100 kPa, so this is representative of what we'd expect for a naturally aspirated engine type of target lambdas. Now, once we've set up our target lambda table and we have our wideband integrated to our Motec, as we talked about setting up a wideband, specifically the UTC module, we're going to find that we're ready to turn on the closed loop control. So we have to have our target lambda table sorted out, and we have to have a wideband integrated. Then we can move down here into our lower window under the calibrate option, and we can go to the closed loop in the mode, and we can turn this on. We can start to take a look at some of our programming details. I'm going to go ahead and do a store to the Motec so it understands that we want that to turn on, and we want the closed loop to become active under the conditions that we're programming. Now the next thing we need to consider is going to be the activate conditions. We also have some fault conditions we need to talk about. Then we'll talk about the actual control, the gain, the averaging, what this all means. So let's jump in here. So under the activate, we need to have some thresholds that have to be met in order for the closed loop control to turn on. Now the engine speed here is the very first one. I usually have 500 RPM set here for the minimum RPM for the closed loop correction to make any adjustments. Usually idling around 800 to 1000 RPM. I don't want my closed loop activating and doing anything from below 500 RPM, so that's sufficient. Some people put the RPM minimum, this is the engine speed with the threshold here, but the minimum RPM. Some people set it higher than idle, so 1300 to not allow closed loop at idle. I don't find that to be very effective. You can absolutely have your closed loop activated idle. There's no reason not to. So I'll set my engine speed threshold here to 500. Inlet manifold pressure, that's the minimum throttle or the minimum manifold pressure, map pressure reading coming from your map pressure in order for the closed loop to turn on. This is generally used to block out closed loop control in overrun. So in overrun, we know we lift throttle. That's going to be where the engine pulls the highest vacuum. That's going to be somewhere here, 0 to 20, let's say kPa, if you pull pretty good vacuum out of your engine. So you'll be sweeping down through here. We may find the overrun fuel cut turns on, which creates a really lean condition. We don't want the closed loop control fighting and chasing and working against the overrun fuel cut, where we know the Lambda is going to have a full lean mixture reading. That can cause some problems there. So this can allow us to filter out any operation in overrun. We also have another way to do it, a better way to do it, which is going to be found down here in a min-max tables. We'll talk about this in a couple minutes. So I'll leave it at 25 kPa. That should be.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.